Hey guys, today we're going to be going over lesson 7.2. This is I can write, solve, and graph one-step inequalities. So let's get it started. So lesson 2 starts with one-step inequalities. Example 1 is about writing a one-step inequality. So you're going to write a one inequality from the sentences. We're going to do 5 together. You're going to do 5 on your own, and then I'll check over it. So let's start with writing a number. Hold on. Sorry, guys. There we go. A number added to 5 is greater than 12. Well, we don't know what a number is, so we're going to use x for that. Unknown values always get a variable. And added means we're adding. And 5 is number 5. And is greater than. Is greater than is, well, if we go back and look at our box, is just greater than. This means it's going to be bigger than 12. And that's it. That's how you write it. All right, the next one, we have the quotient. Quotient means we are dividing. And if you want to make little notes on this, I like doing that. I know this means adding. I know that means a number, and I knew that meant 5. I have it already written out. Greater than is a greater than sign, and then we have 12. Here we have a quotient of a number, which we don't know, and 2 is at most. At most was our, that means it can't be any bigger than a number, so it's less than or equal to 6. So we say x divided by a number, because remember we always go in order for division, is less than or equal to 6. Because it can't be any more than 6. So 7 multiplied by a number is less than 16. So we have 7, we're multiplying, and when we multiply a number in a variable, we just put them together, and it's less than 16. Use our less than symbol. Finally, we have 17 is greater than or equal to, it tells us exactly what's right, 8 less than a number. So we have a number, and we're going to make it 8 less than by subtracting 8 from it. And that's how you figure those out. Go ahead and try the next 5 now, or go ahead and do it after the video. Example 2 says solve and graph one-step inequalities with addition and subtraction. So solving for, and I'm going to just fill these out real quick and come right back. So solving for equations and inequalities are the same for addition and subtraction. There's no difference. Literally, guys, it's just going to be a different symbol between them. Instead of an equal sign, you'll have an inequality sign. So let's practice that. So we have the equation here, x plus 6 equals 2. So we say subtract 6 on both sides, and that gives us 0 here, so we're left with x equals 2 minus 6 equals -4. And how that would look on a graph is we would make a point at -4. That's the answer. That's it. It's just 1 point, right? Versus over here with an inequality, we say, again, we're going to subtract 6 from both sides, and that leaves us with x less than or equal to -4. So now we're going to make our close point again, because it's a less than or equal to, at -4. But this time we're going to include all numbers that are less than or equal to it. So there we go. This one has all real numbers less than that point. So -4 was our point, and everything less than that is included in our solution. This has one number as a solution. This has many numbers as a solution. The only difference when you're adding, subtracting, multiplying, dividing, it's a little different, but we're focused on adding and subtracting right now. So one variable equations gave us one number as the answer, versus inequalities have more than one number as the answer. And that's really the only difference when you're adding and subtracting. So let's go to the guided practice. So we have 15 is greater than or equal to a plus 17. Well, we need to get a by itself, so we're going to subtract 17 on both sides because it's a positive 17. This will give us 0. This will give us -2 is less than or equal to a. So now we're going to go ahead and place the closed circle, because it's a less than or equal to, at -2. And then we're going to say, well, I'm going to plug in numbers on the left and on the right. So let's try our right first. Well, I'm going to use 0. 0 is always an easy one. If you can use 0, plug it in. Is -2 greater than or equal to 0? No, it is not. So 0 does not work. And here we can even cross it off down here so we know 0 did not work. Well, let's try -5. It's in here. Is -2 less than or equal or greater than or equal to -5? Well, yes, -2 is a bigger negative because it's closer to 0. So -2 is greater than or equal to -5. And I know negatives can get a little confusing like that because it looks like a bigger number, but really it's smaller. Think about it money-wise. I'd rather have -$2 than -5. All right, and so then that's your solution. Let's do the next one. We're going to add 15 to both sides. So we have now 0 giving b by itself. And we have -4, because -19 plus 15 is -4. So we have -4 is less than b. So I'm going to go to -4. It's just a less than sign, so I'm going to leave an open circle. So it does not include -4. And then I'm going to go to the right and the left. Well, again, I'm going to use 0 because that's to the right. Is -4 less than 0? Absolutely. Even if I use 5, is -4 less than 5? Yes. So we know our numbers on the right are going to work. So we're going to draw our arrow going to the right. All right, you guys go ahead and try it on your own. I'm going to move on to example 3, solve and graph one-step inequalities with multiplication and division. So solving for equations and inequalities are the same for multiplication and division, except for one key thing. This is important. If you learn nothing else from this lesson, this is the most important. When multiplying and dividing by a negative, you must flip. And make that real big. Make sure you make it big so you don't forget. This is the most important thing from this lesson. You must flip the inequality sign. So let's practice that. So we're going to start by multiplying by a positive number. We have x divided by 4 is less than or equal to 1. Well, to undo division, we do multiplication. So we're going to say times 4 times 4. We multiply by a positive, so we don't need to do anything to the inequality sign. So we have x is less than or equal to 4. We go down here, we find 4 on here. It is an equal to sign, less than or equal to, so we do a closed circle, and then we need to find numbers that are less than 4. Well, 0 is less than 4, so I know then the numbers are going to go that way. All right, dividing by a positive. Well, we have 4x is greater than 20. To undo multiplication, we do division, divide by 4, divide by 4. So now we have x is less than 20. We do nothing to the inequality sign because we divided by a positive number. So x is less than 20, or I'm sorry, not 20. I didn't do the math. 5. So x is greater than 5. We go to 5. We make an open circle because it's not equals to, and we say numbers that are greater than 5. Well, that's going to be to the right. All right, now we're going to try a negative. And I'm going to show you why this works. So, a divided by -3 is greater than 2. So, to undo division, we do multiplication, -3 times -3. And we have now a is less than, because we multiply by a negative, so we have to flip the sign, -6. Now, you might think, why do we have to flip the sign? That doesn't make any sense. If I left it the same, it would be a is greater than -6. And if I plug these numbers, so what's a number greater than -6? 0. 0 is greater than -6. If I plugged in 0, 0 divided by -3 is 0. 0 is not greater than 2. It doesn't work for the original problem if you check your answers. 5, or we'll not say 5, we'll say 3. 3 divided by -3 is -1. -1 is not greater than 2. So we have to flip the sign so that it makes it work. Negatives makes the sign change. So this one does not work. Don't write that down. It's not what we want. We had to flip the sign. So we went from a greater than sign to a less than sign. A is less than -6. And if we check numbers, if we put in -3, -3 divided by -3, oh, that's not less than -6. I'm sorry, guys. Let's say -9. -9 divided by -3 is a positive 3. 3 is greater than 2, so it works. So we're going to place a open circle because it's not equal to on -6, and it's going to be numbers that are less than, so it's going to the left. Let's try one more. Oops, sorry, guys. we're going to divide by a negative now. So we have 49 is greater than or equal to negative 7b. Well, I want to get b by itself, so I'm going to divide by negative 7 on both sides, leaving me with 49 divided by negative 7 is negative 7. And we flip our sign, less than or equal to b now. So again, remember, because we were divided by a negative, I am going to flip the sign. So now I have a less than or equal to sign. So I'm going to make a closed circle on negative 7. And then, now you have to pay attention because it looks like all the numbers should be less than negative 7, but what it's really saying is I have to read this one backwards. I'm going to have to say b is greater than or equal to negative 7, because what it's saying is negative 7 is less than all the b's. So negative 7 should be smaller than every b we have. Well, that means all our b's are greater than our negative 7. So then that means all my numbers should be bigger. And if you're not sure how to read that, that's fine. That's okay. Just plug in numbers. I know I have negative 7 here. Well, I'm going to plug in 0 on this side, and I'll plug in negative 10 on this side. If I plug in 0 for b, I have 49, or not 49, sorry. I have negative 7 is less than or equal to 0. Well, that's true. But if I put negative 10, so I have negative 7 is less than or equal to negative 10. Well, that one is not true. Negative 7 is not less than negative 10. You think about it as money. You would rather have negative $7 than negative $10. It means you have less money when you have negative $10. So that's what happens when you multiply or divide by a negative. Let's do some practice. Again, that was our guided practice. You guys do this, try these 4, try this, and get it signed. Let me know if you have any questions. All right, bye, guys.